गुड मॉर्निंग स्टूडेंट्स। आज हम इलेक्ट्रिक फील्ड निकालने वाले हैं एट द पॉइंट ऑफ एट सम एंगल्स फ्रॉम द एक्सिस ऑफ द डाइपोल्स। नाउ दिस इज अवर इलेक्ट्रिक डाइपोल्स and AB, and minus q charge is placed at the point of A, minus q at the point of A and plus q at the point of B, and we need to find out the electric dipoles at the point of P, and it makes an angle theta with the dipole axis. This is our dipole axis from minus q to plus q. So we need to find out the electric dipole at this point P. So here the angles POB, angle POB is equal to theta. So here POB is equal to theta. So dipole moment, we know that the dipole moment already P, the dipole moment. Dipole moment of the minus q and plus q arrangement. So we have to align the dipole moment along the direction of this one. If I align, so your dipole moment is from A to B. If I align this P, taken two component of this one is along this one. This is P and this is P cos theta. One component will be along the P cos theta. For this P cos theta, then P will be the point on the axial line. On the axial line, we know that at the axial lines electric fields 1/4 epsilon naught twice P upon R cube is there. So now another component of this will be just making an angle 90. Minus P along this one, minus P, P dipole moment from A to B, from minus Q to plus Q, one component along this one, and another component, just another component will be along this one. So it will be, we know that for this alignment, P will be the equatorial point on equatorial point. For the equatorial point, the electric fields we have 1/4 epsilon naught P upon R cube, P upon R cube. So let us suppose this OP is equal to R. OP is equal to R. We have to resolve the dipole moment. To resolve the dipole moment, in two direction. Now first one is P along this one, its component along this one, P cos theta. First component of P is P cos theta. P cos theta will be along OP. Along OP and in the position of A1 B1 position. A1 B1 position. Now second component of P will be P sin theta. P sin theta. P sin theta will be along this one, along the A2 B2 position. Along A2 B2, normal to OP, normal to OP. Now in the position of A1 B1, in position A1 B1, in position A1 B1, P will be on the axial line, on the axial line of the dipole. So therefore, electric fields, the electric fields will be along this one, along PK. That is the value of E1. E1 will be 1 upon 4 pi epsilon naught. For the axial point, the electric fields will be twice dipole moment. Here, the dipole moment along OP is P cos theta. It means that dipole moment, 2 into 2 into dipole moment in this direction, moment divided by R cube. So R cube is the distance. Now put the value of this dipole moment, 1 upon 4 pi epsilon naught twice P cos theta upon R cube in the directions of PK. Along PK direction. So now this is E1. Now second component of this dipole moment will be along this one, along A2 B2 position. Now its electric fields at the point of P will be along this one. So P will be for this position, for the position of A2 B2. So P will be the PP will be the equatorial point. For the equatorial point, at the equatorial point, electric fields of B2 will be along this one, just normal to OP. It means that in position now in position of A2 B2 of the dipole, A2 B2 of the dipole, P point will be point P. Point P will be equatorial point. Equatorial point will be equatorial point, and the electric field at the equatorial point will be here E2 1 upon 4 pi epsilon naught dipole moment divided by the distance of OP, cube of OP. Now put the value dipole moment. It means that the P sin theta will be our dipole moment. Now the value comes out 1 upon 4 pi epsilon naught P sin theta divided by OP R cube. Now this component will be, this E2 has the directions along PL. In the figure, the direction will be along PL. So now the net electric field at the point of B will be the vector sum of the total electric fields will have. Therefore, our total electric field will be the vector sum of E1 and E2. Now make a parallelogram. This is our parallelogram, and when two vectors along the adjacent side of a parallelogram, the resultant will be along the diagonal. So the resultant will be along diagonal PM. So now the electric fields of E1 and E2, resultant electric fields will be along E2, along PM. Now this value become vector E. Now this resultant makes an angle alpha with A1 and alpha with E1. So now using Vector sum formula here. Magnitude of this one. Now the total magnitude will be mod of E is equal to square of E1 plus square of E2 plus twice E1 or E2. E1 square plus E2 square plus twice E1 E2. Angle between E1 or E2, angle between E1 and E2 will be 90 degree, cos 90. So we know that cos 90 is equal to 0. Now the expressions will be finally E1 square plus E2 square. So here the angles here will be 90 because already we said that PL is normal to OP. So PL directions that has of E2 is normal to OP. That's why along this and along this the angles between them will be 90 degree. So that's why the cos 90 will appear here, and cos 90 is equal to 0. Now putting the value of E1 or E2, this is E1 and this is E2. If I solve these ones, now here E will be in magnitude, putting it all under the square root. Value of E1 is equal to this one, 1 upon 4 pi epsilon naught 2p cos theta divided by r cube, square of this, and next one E2 had the value this one. This is the value of E2, 1 upon 4 pi epsilon naught p sin theta divided by r cube, my square of this one. So here the common terms can out of this square bracket. The common term here p 1 upon 4 pi epsilon naught p upon r cube, it is taken out of the square root. Now this becomes now 1 upon 4 pi epsilon naught p divided by r cube. This terms come outside of this one. And here inside of this one will be 2 cos theta, square of 2 cos theta and square of sin theta. Now p cos theta, square of p cos theta plus square of sin theta. We can use p comes out only here, 2 is there. Now replace sin square theta with 1 minus 1 minus cos square theta. This value becomes, now finally it becomes 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught p upon r cube inside of this one 4 cos square theta, and replace sin square. We know that sin square plus sin square theta plus cos square theta is 1. Now that sin square theta replaced with 1 minus cos square theta. Now this is 4 cos square theta minus cos square theta. Four cos square theta minus cos square theta will be 3 cos square theta. Now the final expressions of the magnitude of electric field at the point of P due to the dipoles at an angles theta with the dipole axis. will be here 1 upon 4 pi epsilon naught P divided by R cube inside of the square root 4 cos square minus cos square will be 3 cos square theta. This is 3 cos square theta minus 1. Now this is the magnitude of this gives you the magnitude of electric field at the point of this one. Since the electric field is the vectors, so therefore we need direction of these ones. Let us suppose this resultant electric field make an angle theta along pk. So now for the directions, tan alpha will be here, tan alpha from the triangles of pkm, from the triangle pkm, tan alpha will be mk upon pk, now putting the value of mk and pk. So now mk in the direction of mk, this is a, because this is a parallelograms, in the direction of pk there is e2. Now putting the magnitude of e2, that is e2, and pk along the direction of pk, the magnitude of electric field is e1. If I place all the value of e2 and e1, here e2 has this value 1 upon 4 pi epsilon naught 1 upon 4 pi epsilon naught p sin theta divided by r cube, and upon 1 upon 4 pi epsilon naught value of e1, it is 2p cos theta divided by r cube. If you simplify this ones, cancel this one, r cube cancel, and the p is also cancelled. Now it comes out only sin theta upon sin theta divided by 2 cos theta. Now sin upon cos will be 10. Now this becomes half tan theta. So now the direction of electric fields along mk. Yes, again reviewing the angles now in the triangles pkm, tan alpha will be perpendicular upon base mk upon pk, and along the direction of mk there will be electric field e2, along the direction of pk along electric field e1, e2 upon e1, and place the value of e2. The e2 has the value this is the value of e2, and e1 has the value of this one. If I place e2 upon e1, cancelled 1 upon 4 pi epsilon naught, p cancel out, r cube cancel out, remaining terms will be sin theta divided by 2 cos theta. Now it will be sin upon cos, and this becomes half tan theta. So now this gives you the direction. This is a equation number, this is our equation number first. Equation number first gives you the magnitude, and equation number 2 gives you the direction of the electric fields due to this dipole along an angle theta from the direction of the axial line, from the direction of p is the direction from minus q to plus q.